Welcome back to Balmer's Workshop. Thanks so much for joining me here once again. It is always great to have you back. This time we're going to be continuing the build on the little Pajero, however you say it, mini rear bumper. We got as far as tack welding the wings onto the center section last time, and we will pick up where we left off this time, of course. It's exciting for me to get back to this one because the vehicle was gone from the shop for a couple of months, so it was nice to continue this and get the build finished up for the customer.
I will say at this point, my spindles that I normally use for swing arms have become unavailable. They worked perfectly for my side kicks, and they would have worked really great for this one too. But I can get a hold of a more heavy-duty, really overkill spindle for this vehicle. The issue with it is that the barrel or the hub of it sits quite high. It's going to wind up blocking this reflector, but I won't block the reverse light or anything above that. So really not a big issue. What I'll wind up doing is just adding a reflector to the hub itself, and then that way everything's nice and legal beagle. So now that we're back down on the ground, I'm going to use an angle finder to set the angle of the bumper because I do have a degree of adjustability. It's sitting at almost 90 degrees to the ground right now. You could just strictly use that as a guideline. You could just go off 90 degrees to the ground is exactly what I want. You're going to set the receiver, if there was one, at at a nice 0-degree angle to hook trailers up to. That makes sense. But in order to make things look as best they can, I always try to match the bumper angle to the vehicle rake, meaning that if the vehicle is raked down, if the front end of the vehicle is lower than the rear, which is very, very common, I kind of try to match that angle. Now, I've measured off the bottom of the rocker panel, which is a great place to get that measurement, off the pinch seam of the rocker panel. I've done that on this vehicle, and it's pretty much dead zero. So I am looking more or less for 90 degrees. I might just pivot it down a little bit because the lines of the vehicle do kind of rake downwards towards the front, but the stance of the vehicle, like I just said, is pretty much dead flat. So I may rake it forward just a little bit to kind of complement those lines, but I want to keep it very close to 90 degrees. So I'm going to use a stand to hold it in place at whatever angle I choose, and then I'll tighten up all my hardware. So right now we're at 89.7 degrees, so we're very, very, very close. So I'll just come up a little bit with it, and we'll lock the stand in place and have a look. 88.86, so I've moved it by pretty much a degree. And I'm just going to walk over to the side. Okay, so let's have a closer look. Again, it's sitting at 88.7 degrees right now. And that rake looks really good to me with the rest of the vehicle. When you kind of look at those lines, like I said, the lines kind of go down towards the front of the vehicle in terms of this body line here. But the rocker panel itself sits at pretty much 0 degrees. So that's why I'm not going far off 90. Push it a degree forward just to kind of match that, the rake of the vehicle a little better, and we'll lock it in right there. So here's that really, really heavy-duty spindle and hub setup that I was talking about. This is by a company called TMR Customs. They are another great Canadian company. They have really, really good quality products, great service, and reasonable pricing as well. So I would recommend them to anybody. I used to use their smaller version, or the smaller version of their spindle, I should say, but they no longer offer that. It was, again, a little bit shorter in the hub, and it worked perfectly for my side kicks because I run into exactly the same issue I was just describing, where I wind up blocking part of the tail light, or at least the reflector part of the tail light, even with the smaller one. With this great big one, with the side kicks, the way it works out is it blocks the actual light itself, so I can't use this on the side kicks, or I'm going to have to come up with a totally different bumper design for the side kicks if I do want to use that. But hopefully I'm going to get a hold of those smaller spindles for that purpose, but this one's going to work, I hope, for this one. But what I need to do is figure out just exactly how high this hub sits on the spindle once everything is put together. So what I'm going to do now is just remove my bearings from the packages, drive the races into place, and actually just dry assemble this thing really quickly, and then we'll put it in position on the bumper and measure the height, and I can put a piece of tape on the tail light where it will wind up. And that gives me obviously a reference to move on with, and we can see whether we can get away with leaving it at the height that it's at or not. So I'll put this together and show you what I'm talking about. And there we are, assembled and ready to go. So now we'll go over to the truck and put this in place, and then we can make our measurements like I said. We could also make some reference measurements just by recording how far above this shoulder the very bottom of the hub goes, and then obviously just measure the length of the hub to be able to relate that later as well. And then that way, if I lose my mark, if I use some tape and the tape gets knocked off or whatever happens, at least I'll still have a reference for the exact overall height of this. Plus I can measure from the one end right to the other as well. So 3 different reference points. All right, so I've already taken the measurements that I talked about. I measured the overall length, and the way that I did that was I just set my spindle and hub assembly on a flat surface and set my square just like so. Using a square is a little more accurate than a tape measure. I find I like to use a square whenever reasonably possible. So I found that it had an overall length of 10 inches, and I found that the bottom of the hub sits 1/8 of an inch above the shoulder of the spindle. I'll show you what I mean by that. Again, there you go. There's exactly 1/8 of an inch from the bottom of the hub to the shoulder of the spindle. So now we'll take this and mock it up in position. I can actually see a faint line where I had marked a potential spindle position before when I was building this bumper, and that is where it will sit. So you can see it's going to be perfectly in line with the bottom of the reverse light. So we're going to be nice and legal so long as we put a reflective sticker on there, which I will do. So that looks pretty reasonable. Now, because I've cut the end of my wing here down to 2 inches, where with a side kick it would be 3, I've lost a little bit of the material here. And if you look again, you'll see that I'm going to have a fair bit protruding out right here. So what I'll do is I'll hole saw my holes top and bottom for the spindle to go through. I'll drop the spindle through, and then I'll just trace around the spindle so I can see exactly where it's protruding. I'll put this in the band saw. I'll have to block it up. Or maybe I'll show you how I'll do that, but I'll have to block it up in a creative way, get this into the band saw and cut that. Or if that doesn't work out, I'll even just use a zip disc to cut it and smooth it all around. And then that way we'll have just a little bit protruding where I can run a nice weld bead along the bottom there. And of course it'll be welded along the top as well. So that's pretty slick. Now, one other thing I should mention, this is 2 inch by 5 inch tube, and the wall thickness is 3/16 of an inch or 1/88 of an inch, which gives us an internal cavity of 1 5/8 inches. This post is 1.5 inches, so it fits in just perfectly. Some companies try to build their products up even more than this, and they'll give you a Trail Gear is a good example of that, and they'll give you a post that's 1 3/4 of an inch, which, yeah, it's even stronger, but it's unnecessarily stronger in almost every application, in my opinion, and it means that that won't fit through the 1 5/8 cavity that you have in a 2 inch tube or 2 inch, 2 inch by whatever tube. And this is really common material to use for bumpers, so it's nice to have a post that is 1.5 inch diameter. So thanks again, TMR, for that. So I kind of got ahead of myself a little bit. We started talking about the spindle setup and all that before I kind of went over the basics of this bumper. Because I had started constructing this so many months ago, I was excited to move on and make some progress. But I should back up a bit now and tell you how I made some of the most basic decisions concerning this bumper. So of course, center section width is a concern. You want to obviously complement the shape of the back of the vehicle, and I think I've done that. You know, if we look here, the vehicle's virtually straight until about this point, and then we angle in. I think I angled in at 12 degrees. Let me grab an angle finder and we'll just check that, or protractor, I should say. Yeah, 12, 13 degrees is what that is, which is pretty similar to what I use for side kicks, and it matches the vehicle well. And the other thing that you want to consider when you're creating your center section is that the width is wide enough that your mounts are going to mount up to it. Because this is obviously a flat piece, it's a whole lot easier to mount your mounts to that rather than it is to an angled piece. And also it's a little stronger because you're going to avoid a welded section. You're going to go straight from a solid piece of tube straight to your mount. So the way that I've positioned it, my mounts wind up just at the very outsides, and as you saw before, they're gusseted up to the back of the bumper. So center section is decided on the shape of the vehicle and the width of your mounts. Those are your two critical considerations. And on the Pajero Mini, I chose to go with a 36-inch center section and again 2x5 tube. My wings are 10 inches long, and they tail up to 2 inches here, and the point at which they begin to tail up is at 3.5 inches. So there's your dimensions if you want to build one of these yourself. The wings were cut with a plasma cutter and then capped again with a 2-inch flat bar. You could use a zip disc to cut these just as easily. Plasma cutter is just a little quicker and cleaner. As the build progresses, I will of course build a top plate for the bumper so that we don't have this big open area here. It'll just be a nice checkered top plate, similar to what I do with my side kicks. And I'll take you off the tripod now and give you an example of that. So here's a couple of side kick bumpers, a front and a rear. This is a non-swing out rear, but this is what I was talking about as far as the top plate goes. Just something to cover up all that metal work that you would see if it wasn't in place. But just as note, these holes are to access mounting positions. They probably won't exist on this bumper because I don't think there's anywhere up there that I can choose for a mounting position. So just as I was getting started with this whole swing away idea, I discovered an issue. And this is the thing with custom stuff, is there's so much to consider that sometimes once you make a decision, you have to remake that decision. Can you see the issue here? I'm actually touching the tail light at this point, and of course I don't want that. I want to be at least a half an inch away from it. And look at the relationship between this tube and the hub. The spindle isn't installed right now. There's no spindle in place. I just have the hub sitting on there. But you can see that the hub is way forward, or rearward I should say actually, of center of this tube. I apologize for my voice. I have a plugged nose today, so if I sound really nasal, that's why. But anyway, this spindle is not going to wind up working out for the position that I have the wing in, so I'm going to have to bring the wing back a little bit. Right now, as I said, it's sitting on a 12-degree angle. I've done a little calculation, again using the protractor, and I basically just positioned it so that I could see where I wanted to wind up, and it was about 8 degrees. So what I'm going to do is cut the wing off the bumper. It's just tack welded right now anyway, so we'll cut the wing off, we'll clean those tacks off and so that it'll fit in the bandsaw nicely, and we'll adjust this 12-degree cut down to 8 degrees, and we'll see if that's going to work for me. So here's a little tip. Sometimes you might need to cut a piece which you have already modified. In this case, I've welded a plate to the bottom of here, and I have a great big weld going up the side here. Now, if I tried just to put the vise jaw against that, of course, it would sit there and rock, and it wouldn't have a proper surface to mount on. So I've just included, I'll back it off a little bit here. I've just included a little piece of 1/2-inch flat bar so that it sets the jaw back past the point where it's going to contact that ridge, and then that way it clamps up nice and flat. And also in my hand, you'll see that I have an angle finder, digital angle finder, very handy tool and not expensive. And that is going to allow me to set my angle correct to this deck, because of course I'm sitting on a really short little 3.5-inch segment here, so getting it flat just by feel is going to be pretty challenging. So I'll just check my angle on my deck, I'll match it here, tighten it up, and then we'll run the saw down now at 8 degrees instead of 12. So my deck is sitting at 0.62 of a degree down this way, so of course I want to set my tube exactly the same. And there we go, 6.2, perfect. Or at least very, very close to perfect. So now, as long as I am on the portion of the tube that I want to be, I can go ahead and cut.
All right, so now that I have changed that angle from 12 degrees down to 8 degrees, I'm going to go ahead and bore out the holes for the spindle to go through. Those are 1.5 inches, so I'll use obviously an 1.5 inch hole saw to cut those, and I can still see that faint line that I was talking about right there. So I'm just going to go ahead and use that because it looked like it was in the perfect position. So I'll just remark that. I'll kind of transfer it around the corners so that I can see it on the bottom and the top. And now I can mark centers. Now let's start with the top. The top of the tube is unadulterated, so I can mark it. Let me make sure that I'm on exactly an inch. In this case, I've chosen 4 inches, but that means that now I can go ahead and just draw my center line, and that's going to be for the top of the spindle to drop through. However, on the bottom, I have this welded plate, which is offset. You can see here it actually hangs over this side, whereas it's inset from this side, so that I could put a nice corner bead on that and blend it down nice and evenly. And then here we have a weld which isn't exposed. But that means that this measurement is no longer exactly 2 inches, so I want to be sure that I measure my 1 inch center from the face of the bumper, not from the back side where this plate hangs over. And there we go. So I'm just going to center punch these, and then we'll drill them out with a hole saw. All right, so I've drilled the holes. I opened this one up just ever so slightly because I was just off-centered, so I was away from the inside wall on this side of the tube, so I just ground it out a little bit, and it fits through, or the spindle I should say, fits through very, very nicely now and right into the bottom. And you can see that it's sitting dead flat on all aspects on the nice machined surface, so we know that we're good to go in terms of welding that in if we wanted to. I certainly wouldn't do any more than tack welding it at this point, but we could do that. Like I say, this is sitting on a true machined face, and we want this to sit at a dead 90 degrees to the top of the bumper. The swing arm itself will wind up being angled up slightly to account for the weight that's going to be added to it, but we don't want to angle the spindle because that will change the arc of the swing arm. We want the swing arm itself to be angled up slightly, but we'll come to that later. The important thing to understand now is you want your spindle to be dead 90 degrees to the top of the bumper, and that we've accomplished. Now, the issue there is, I'll take you off the tripod for a second. So the issue that exists now is with the bottom of the spindle. You can see that the bottom here is recessed just slightly, which will actually make for a beautiful weld prep area. But this side sticks out a little bit more than I would like when we look at it from the back. You know, it's just a little chunky looking. So what I'm going to do is what I said earlier. I'll just trace that out with a marker, and then I'm going to take a sanding disc and just blend that down slightly so that we get about a 1/4 inch sticking out around here rather than what we have right now, which is about 1/2 inch, maybe 9/16. And then that way it's just going to look a little cleaner when I run a weld. But fits up really well otherwise, and it's looking great. So now we can go back to the vehicle and tack the bumper sides back on. I did, of course, remove the driver's side, or sorry, this was the driver's side. This is a right-hand drive vehicle. I did also remove the passenger side, or left-hand side bumper wing, so that we could adjust the angle on that, and that has been done. Of course, anytime we adjust something on one side, we generally want to do it on the other. In this case, that's certainly true, in order to keep the symmetry of the bumper. All right, so we're ready to weld on the wing again now that we've adjusted the angle and created the hole. I've taken the spindle out for now, or holes, I should say. I've taken the spindle out for now. I'm happy that it sits dead flat on that machine surface, like we said. I can add that in whenever I'm ready, and it would just be awkward to have it in right now, and it would be potentially could get damaged. So for me, it's better to
to leave it off for the moment. Anyway, what we're gonna do is set some magnets up just off the bottom of that bottom radius so that we're gonna be nice and flush on this face here. We'll do the same at the top. Make sure we don't have any debris stuck to the edges of the magnets so we have a nice clean surface to go on. And one more up top. And although this is a pretty busy looking arrangement, I'll show you why I do it this way. No, we're not going to take a phone call right now. Okay, so that way I can ensure that all faces are nice and flush. And what I want to do is set the inside of the joint together and have a gap of the correct weld prep at the back here. That way, I've got the correct weld prep, obviously, so about 3/16 of an inch, since this is 3/16 wall material. Pardon me. So that'll be correct, but more importantly, once I've then tacked that up, I have flush faces, and I'm going to be at a little bit too tight of an angle because, of course, these inside faces are touching. But that's a good thing because I won't be able to force it any more closed, but I will be able to open it up quite easily. I can use the tack welds here as a hinge. And once I achieve the correct angle, then I can tack in here, and that way I've got perfectly flush faces and the correct angle. So that's why I do it in that order. So let's make sure those inside faces are pressed together. Let's ensure we have our correct weld prep, which I do now, and we'll put a tack down. Now, with any luck, that's going to be just a little tighter of an angle than I need. And like I said, all the faces should wind up flush. Before I tack the bottom, what I want to do is check to make sure that I have a perfectly straight top to it. So let's remove this magnet, grab a straight edge, whoops, knock our other magnets off by accident, and fill them with metal debris. Put our straight edge on, and yes, indeed, we're nice and flush. If this were down at all, I would correct for that before I did this tack, but it's perfect. So we'll simply do the bottom tack, ensuring that our faces are flush, and they certainly are. And now I've got that hinge joint, so to speak, that I was referring to. Let's grab a protractor, and we're looking for 8 degrees. And that is 9.5. So just like I said, we want a little less, so that's perfect. That means that I can just by hand open this up a little bit. I can see now that I've got just about perfect weld prep at the back, so I expect that should be just about 8 degrees. And it's 8 degrees. So there you go. Now I can tack that inside one, and as I do that, I'll put a little back pressure because it's going to want to shrink in a tiny bit, so I'll just hold a little pressure on it while I tack it, check it again, do the bottom, and then we can move on from that point. Just light back pressure. And we'll hold that pressure till the color is gone from the tack weld. Recheck it. And so long as we are at 8 degrees, we can do that bottom inside tack. And we are at 7.5, I would actually call that. So we're a tiny bit tight, but being as it's only a half a degree, what I'm going to do is not bother doing this inside tack, and we'll drop our spindle back in, put the hub on it, and see how it looks, and then we'll move on from that point. I should mention, if it works out, then obviously I'll mirror that 7.5 degrees on that side. I won't go 8 degrees on one and 7.5 on the other. I'll just do them both at 7.5. All right, so that did technically work, but we're pretty darn close to that tail light. I've got just over a 1/4 inch, 5/16 of an inch or so between the hub and the tail light. and that's just not quite enough to make me comfortable. I'd like to almost double that. I'd like to see half an inch anyway. So what I'm going to do is just cut this inside tack, and then we'll just open this up again, reinsert the spindle, get it positioned at about a half an inch, tack it, and then we'll check the angle. If there's a considerably larger gap on the inside at that point, then I will remove the wing again and recut it in the saw. But if it's very negligible, then it won't be a big deal just to weld that up. So we'll see how that turns out. All right, a couple of days have passed and some progress has been made. I was away this weekend at a wonderful wedding for my friends Gord and Carrie. Congratulations to the two of you. And I have not gotten a lot more done since the last filming, but I have done these sides, as you can see. These are also made from 2x5, the same tube that the center section and wings are made from, so it's all the same material. All I did was cap the ends with some 2" by 1/8 flat bar, or 1/8 by 2 is the correct way to say it. Flat bar on the ends there, overlap that on the insides, and welded it up. And then for the back here, I basically just went right up to the bottom of the tail light, made a mark on the top of this tube, made a mark at the radius of the wing there, and connected the dots, and that's how I came up with that line. In terms of this angle here, I just tried to match the look of the vehicle as good as I could, and I think it's turned out really well. And we positioned it just wide enough that it's not going to contact the body, so that it sits as tight as it reasonably can. One thing I kind of overlooked is that this leg is just a little shorter than this one, so I'm going to wind up having to put just a bit of a fill plate in there once I cap this, because I'm going to cap this portion obviously to make it look good and clean. If we go over to the other side, you can see a better example of that. I've already capped this. This is done differently, of course, because on this side we have the spindle to look out for. On this side we do not. So I've faired this whole area in a little more completely. And you can see again, this angle is exactly the same as on the other side. And this leg in here is a little short, so when I pull the bumper off the vehicle, I'll show you that I'll have to put a little plate inside of there just to fill things up and make sure we don't have any water getting inside of the bumper, which will cause rust, of course. So I put a cap on the top. I don't know how easy that is to see in the light here, but this is capped up on top, and obviously our back panel, and then we've got an inside panel as well. And now we'll do a top plate that covers up all this area, checkered top plate, and we'll kind of box it in back here so that no water comes up from the tire to hit the backside of this spindle. So that's kind of the process that I'm going to go through today. And once we've got all that stuff complete, then we'll move on to creating the swing arm itself. And there you are. The top plate is complete. I've just clamped it in place with an F clamp for now, just to make sure it fits really nicely and it follows all of the bends really well and fills right to the back of the vehicle while still having, you know, a good 3/8 of an inch gap all the way along, so it's not going to ever rub the body or anything like that. And now let's have a look. I'll just close the door slightly onto that F clamp gently. And now let's have a look at this corner that I faired in. So like I said, I just capped the back of that 5x2 tube where I had cut it on the angle, 75-degree angle. And I don't know if you're going to be able to see very clearly in this light, but I've put a panel in behind there so that we won't have any dirt and grit spraying up, and also one along the side here as well. So basically just creating a little cavity for the swing away hub to sit within, where it won't get sprayed by any debris from the rear tire. But it's coming along really well. I'm very happy with it. That was a pretty straightforward build, if I'm honest. Normally I would take time lapse of all of the actual build going on. This time I'm just really short on time, setting up cameras and so forth. I've got a lot on the go at the moment, and so I'm missing a little bit of the video content, so I apologize for that. This is the best I can do for you. If you want more tips and tricks on metal finishing, metal cutting, how to find your best way to get these shapes and so forth, check out my other Suzuki videos, Suzuki bumper videos, and you'll get a bunch of information there. There's also a good rear bumper video on a van that I did that you might want to get that kind of information from. But in this video, you'll at least get an understanding of what I have done, what steps I've taken to get this thing to come to fruition. I removed the spindle so you can get a better look at the little fairing or cowling that I made to protect the spindle from debris from the rear wheel, like I said. And I also have a cap to go up in the top here, just like I do over on the other side, but I haven't added that. I'm gonna take the bumper off the vehicle now and complete all this stuff, get the top plate welded on, get that cap in there, brace it up and fully weld it, I think, because it's pretty much at that point. We'll add some recovery points to it. I've just talked to the customer. He's decided he now wants to add a 2-inch receiver on the back that will allow him to put a cradle mounted winch in there should he want to, or add a bike rack or any other receiver mounted accessory. I don't imagine he'll ever use it for towing anything, as this vehicle is very, very underpowered and it would struggle to do so. So let's remove this bumper now, and we'll have a better look at the back side of it, or the inside of it, and we'll get it nice and complete, and then we'll move on to the swing arm. The bumper is mostly welded up now. I left a few parts, such as the mounting brackets I haven't welded, and the receiver I have not welded. My reason for not welding the mounting brackets yet is just in case when I put this on, if I want to make any adjustments to pitch or yaw or any angles like that, I can still remove those brackets and shift the entire bumper to suit what I need before fully welding those brackets. And I'll also brace these brackets together like I've done with the ends of the bumper here when I do weld them, so that I don't get any heat warpage. But for now, we'll leave them just tacked. I'd like to mount the bumper back on the truck and have another look at that receiver and just make sure that I'm absolutely 100% confident that it is perfectly straight in line, 90 degrees to the ground. So I'll fully weld it after I've confirmed that. And the recovery points here I have not fully welded yet either, and my reason there is because I want to make sure that my latch doesn't interfere here. I may end up having to move these a little bit. I don't think so, but just in case. But I have fully welded all of my fairings here, and you can see the heat penetration because I welded the back side of this 2x5-inch side panel or side portion. I've welded that in, and I'll turn the bumper around and give you a better view of that. So that seals it up for any water ingress. You'll remember earlier in the video I showed you that this leg was just a little short compared to this one, and there was a bit of a gap in there, but I was able to just weld that up, no problem at all. Now on this side, I have not finished those welds. I'll turn the bumper so you get a bit better lighting there. I have not finished these welds, and the reason is because if I did, obviously I can't remove this anymore, and I wouldn't have room to get in here and do my backside welds. So I'll turn the bumper around and show you what I mean. Okay, so looking at the bumper from the back side, if we look up in here, you can see that I've fully welded the side to that fairing or cowling, like I said, and that way no water can get in there. However, over on this side where the spindle will be, I just don't have room to get in there to do my weld anymore. So what I'm going to do is just remove this panel. So what I'll do is just cut these tacks here and up here, and I'll remove all three of these pieces as one piece, and then that will allow me to get in there, weld. Then I'll put this section back in and fully weld it, and then we'll add that top plate as well. But I just wanted to show you that it's important to kind of consider things as you go, because of course if I fully welded this guy up, I would no longer be able to get in there, and I'd be stuck using seam sealer or something to seal that up, which really wouldn't be the end of the world. But since we have the opportunity to weld it solid, that's what we're going to do. And there you are. I removed that piece of cowling, and you can see by the heat penetration there that I have fully welded that gap. This time I used a little fill piece to cover up the gap. It was a little bigger on this side, and she's nicely sealed up now. No water's going to get in there. And I can simply take that piece of cowl or fairing that I created and just add it right back in again. So we'll just sand off the tack welds and position that back in place with some magnets, making sure that it's nice and flush to the correct surfaces, and then we'll weld that up and blend it out as well, and then we'll add that little top piece that goes in there. And there it is, tacked back in place and ready for full weld up. I'll just pop the spindle back in there so you can see that it fits well. And there we go. Good clearance all around. I'd say I've got 1/2 inch in here and about 3/4 inch back here. And then over on this side, about, again, 1/2 inch or so. And now, of course, we'll add the top plate in here, and that will kind of complete everything. I added this little gusset as well, not for strength, but just so that it offers a little bit more protection against rain and debris coming back from the tire. But there it is, the top plate's on, and it's ready for full weld up. There we go. Welded, sanded, blended, and all finished. So now I've got a nice little cavity or alcove for my spindle. Everything's finished up with that. The top plate's on, everything's been faired out nicely, and I'm very happy with the way that it turned out. Now it is time to add the top plate, which is sitting right there. So let's pop that in place and give you an idea of how it's going to look. So there we go. You can see that it follows the lines really nicely. And I've got virtually no gap in there. Little rounded corner. Come over here and we've got exactly the same deal over here. Really nice fit. So I'm going to clamp this down with some F-clamps. Make sure it's nice and tight to the bumper itself. And then we'll tack it in place, remove the clamps, and fully weld this guy. And then it's time to place this bumper back on the vehicle. We'll make sure that I'm happy with the positioning of the bumper itself, which again can be adjusted via moving those brackets if I absolutely have to. We'll confirm that the receiver sits exactly 90 degrees to the ground, then we'll fully weld it. And same thing with the recovery points. We'll just make sure they look exactly straight, and then we'll remove the bumper one last time and do the final weld up. But right now I will get this top plate in place, and we'll move on from there. And there we are. Top plate has been added, and I have installed the spindle. I just tacked it on the front sides here in case I need to remove it again. I did not tack it back there, but of course I wanted to make sure it was stable and and it wouldn't easily move out this way. So I also tacked on the bottom there on the inside, and I also created that chamfer like I talked about earlier so that this matches the angle of the bumper, and it gives me a nice 1/4 inch segment to kind of weld around there. So we'll do that once we're completely confident with everything. I'm not going to fully weld the top plate at this point. I've just got it tacked in place. And then obviously same with that spindle. So let's get this back on the vehicle, make sure that we're happy with absolutely everything. And if we are, we'll pull it back off one last time and fully weld everything. And then it's time to move on to the swing arm. And there we are. The bumper is back on and it fits very well. It did not fit perfectly with my first attempt. This is a second attempt, and I'll show you what the issue was. Hopefully I can get enough light in there to show you. This top plate was just a little large towards the back here. Don't know if I can get my light in there well enough for you to see, but it was just contacting the body of the vehicle just slightly. So I've trimmed that back slightly now, and it fits up really, really well. My angles are good. Very happy with that. And the fit and finish is very, very nice. So now I can move on to creating the swing arm,
which we will be moving on to in the next and final episode, part 3 of this Pajero Mini rear bumper build. Please come back for that one. I appreciate your patience in waiting for these episodes. I know I've been taking absolutely forever in turning them out. I think it's been 2 months since I did part 1. But if you look at my last upload, that was only 2 weeks ago. And for me, that's a pretty good turnout. The reason that I've been able to do that a little quicker now is because instead of being stuck using my office computer, which was the only one that I had that was powerful enough to edit on, I can actually edit at home now. I bought myself a laptop, and so that speeds things up a whole lot for me. I don't wind up at work 7 days a week, thanks to doing editing on the weekends. So stay tuned and expect a little quicker uploads from now on. Thank you for your patience. Thanks for joining me here at Balmer's Workshop. See you next time.